Have you ever just looked up at the night sky and thought about what you're really seeing? It's just countless galaxies out there, these immense, sprawling cities of stars, and every single one has a history that's billions of years long, full of absolutely epic events. But here's the thing, they didn't leave any records. So how in the world do we read their story?
You know, that's one of the biggest puzzles in all of astronomy. Just try to imagine reconstructing the entire history of some ancient city, but you've got no books, no maps, and absolutely no one left to tell you what happened. That's exactly the kind of challenge astronomers are up against. So, where do you even begin? Well, the answer comes from a field with, honestly, a perfect name: Extragalactic Archaeology. And the core idea here is to stop thinking of a galaxy as a history book you can just read. Instead, you have to treat it like a giant cosmic fossil record that needs to be unearthed. The central concept is really elegant. Every single star inside a galaxy is like a tiny fossil. The light it gives off and the exact path it travels, all of it contains encoded information about the galaxy's super dramatic past. We're talking everything from massive bursts of star formation to incredibly violent cosmic collisions. Okay, so if the stars are fossils, how do you actually, read them? It turns out these cosmic archaeologists have two primary tools in their toolkit, and the first one is all about decoding the secrets hidden inside the starlight itself. So scientists use this technique called stellar population models. Probably the best analogy for this is like taking a census of a huge city. I mean, you can't possibly go interview every single person, right? But by analyzing the city's combined data, like how much light it gives off at night, you can build a really accurate profile of who lives there. These models do the exact same thing, but for the combined light of billions of stars. And what does this cosmic census tell us? It's actually amazing. From all of that blended light, scientists can start to tease out the ages of different groups of stars. They can figure out their chemical makeup, and they can even piece together a timeline of when and where that galaxy was going through its biggest baby booms of new stars.
But starlight, that's really only half the picture. What about all the stuff we can't see? The huge majority of a galaxy's mass is this invisible dark matter. It's like the gravitational scaffolding that holds the whole thing together. So how on earth do you map something that gives off no light at all? For that, we turn to the second tool, something called dynamical models. Let's stick with our city analogy. Imagine if you could map out an entire road system, including all the hidden subway tunnels, just by tracking the movements of thousands of cars. That's what this is. By studying the precise orbits of individual stars, astronomers can map the entire gravitational landscape of a galaxy, and that's what reveals those massive, invisible structures of dark matter. This method is just so powerful. It's kind of like forensic physics. It allows us to weigh an entire galaxy, trace the shape of its enormous dark matter halo, and even measure the mass of that supermassive black hole hiding right at its core. Now, one of the most sophisticated techniques they use is called Schwarzschild's method. It's a really clever way to take this chaotic dance of billions of stars and sort them into different groups based on their orbits. You're essentially untangling the whole cosmic mess into its fundamental moving parts. So we have one tool for reading the starlight and another for mapping the motion. But this is where the real magic happens, when scientists combine the two. That's when a galaxy's most epic histories finally start to get uncovered. By merging the data on what the stars are made of with the data on how they move, the full story just snaps into focus. The fossil record opens up, and suddenly you can see the step-by-step assembly history of a galaxy playing out across billions of years. And this reveals some incredible things, like the faint ghosts of past mergers. You'll suddenly spot a group of stars that have a unique chemistry, and they're all moving on a peculiar path together. That is the undeniable signature of a smaller galaxy that was swallowed whole long, long ago. It also uncovers the slow, inside-out buildup of those beautiful galactic disks. You can see how the oldest stars settled down at the core, while younger generations of stars formed further and further out. It's kind of like seeing the rings of a cosmic tree. And it helps us solve major puzzles, like the origin of those really dense cores you find in galaxies. We can finally start to figure out if they were formed by violent mergers, or if they just grew slowly and organically over cosmic time. Look, uncovering one galaxy's personal story is fascinating, for sure. But why does this matter for our understanding of the entire universe?
Well, because this work provides a crucial bridge, a way to connect our time, right now, to the very beginning of cosmic history.
Just think about it like this. Our view of the nearby universe is super detailed, almost high definition. But it's just a snapshot of today. Our view of the early universe is ancient, which is amazing, but it's also faint and really blurry. Extragalactic archaeology is the bridge between them. It lets us use the fossil records of nearby galaxies to fill in that huge gap in our knowledge.
And that bridge serves a really critical purpose. You see, astronomers have these incredibly powerful simulations that make predictions about how galaxies should have formed, all based on our fundamental theories of the universe. Well, extragalactic archaeology provides the hard, real-world observational data, the actual fossil evidence, to go and rigorously test those predictions. It's literally how we find out if our grand theories of the cosmos are actually right.
So by learning to read the history written in starlight and stellar motion, we've opened a completely new window into the past. And this is just getting started. The universe is this vast museum filled with clues about its own creation. And with tools like these, we're finally starting to unearth its greatest secrets.